chemistry session. So we have already learnt about what is isomerism in coordination compounds. We have already learned in detail about what is geometrical isomerism. So today we will have some FAQs related with geometrical isomerism. So let's see one example. Draw geometrical isomers of the complex compound PTNH3 twice Cl2. So what's the question? We have to draw the geometrical isomers of the given coordination compound. And the compound is PTNH3 twice Cl2. So the first thing what you have to see is we have to find out the coordination number of that particular central metal atom or ion. Only then you can predict its geometry, right? You know it. Only then you know which polyhedron we have to, this particular complex compound is having. So what is its coordination number? Here we have amine, two amines, and we have the Cl ligand, that also 2. Both are unidended ligands. So 2 plus 2, 4. So the coordination number of platinum in this particular coordination compound is 4. So the predicted geometry we can have is square planar. We can have the square planar geometry. So it's ready. We know it can have a square planar geometry. So let's see how to arrange it. Platinum, the central metal ion should be in the middle. That's kept in the middle. Then it will have a square planar geometry. So we'll draw a square. And then each corners of the square, the ligands will be placed. So we have the 4 corners of the square, and in each of these corners we can keep the ligands. So we have Cl2 here and NH3 twice, 2 NH3 here. So we have the Cl and keeping Cl here one side. So if we want to get a cis isomer, you know that cis means near to. Identical isomers should come near. Okay. So Cl I have kept here and Cl again I have kept here. So that made this chlorido ligand or Cl ligand became cis, near to. And then NH3 I have kept here. NH3 ligands I kept in these 2 corners. So we have got the cis form of this particular coordination compound. Okay. So the name of this compound right now is cis PT NH3 twice Cl2. That means you can name this compound as usually you name, and you have to add cis. And then we can now the cis form is ready, and this is a very important compound. You are familiar with this compound. You have learned it in class 11. This is cisplatin. This is cisplatin. What is cisplatin? It is an important drug which is used as anti-cancer drug. So cisplatin is an anti-cancer drug. That makes it very important. It's used in the treatment of cancer. It's an anti-cancer drug. So you should know its formula. You should know its structure. What's the structure of cisplatin? What's the chemical formula of cisplatin? You know it. This is the cis form of this particular coordination compound. And then let's see its transform. How it will look like. You know that trans means across. It should be the identical ligands should be placed as far apart as possible. That means around 180 degree. So here we have a central metal atom here, and then we have the square structure because it can exist as a square planar because of the coordination number 4, and then we will keep the 4 ligands in each corners of that square. So here we have Cl as we have done it here, and then the next Cl should come just opposite, which makes the identical ligands as far apart as possible. So here Cl. Okay, and then we have NH3 here, 2 NH3 is remaining. In that 1 NH3 I have kept here, and then the other NH3 I have kept here. So we have done this transform of the given coordination compound also. So this is trans PTNH3 twice Cl2 So this is the trans form of the given coordination compound. And what is special about this? It doesn't have any anti-cancer properties, because we have already learned that this isomers are having a same chemical formula, but it will not be same. They are different because its atoms are arranged differently. So this particular transform of the same coordination compound does not have any anti-cancer properties, but this cisplatin is the best anti-cancer drug that we can get. So let's see one more example. It's an important FAQ asked many times in the board exams. Draw the structure and write the name of the given compound. So we have to draw the structure and we have to write the name of that given compound. So the compound is CONH3 4 times, H2O twice, Cl3. So the first thing is we have to find out its coordination number. Since we have amine ligands and equiligands, both are unidentate ligands. So it's easy to find out the coordination number. So we have 4 amine ligands here and 2 equiligands here. So 4 plus 2, 6. Coordination number of central metal ion here is 6. 6 is the coordination number. If 6 is the coordination number, what is the expected geometry or expected polyhedron? That is octahedral. The expected geometry is octahedral. So we will have the octahedral geometry for the given coordination compound. What is octahedral geometry? There will be a square plane, plus in that square plane, each 4 corners, 4 ligands will be placed, and then one will be projecting upwards or towards the observer and one will be projecting downwards. In any way which is possible for you to remember, you can think about like that. I will draw. So the central metal ion is here, CO. That has no change. We have written that, and we have drawn that square plane. This is square planar structure, and each corners of this square we will have each ligands, and then we have one placing, one facing above and one facing below, or one facing the observer, or one is away from the observer. Anyway, you can think about it. So this is octahedral geometry, and we have to place any 2 we have to place close, near to, then it will become cis. The rest of the ligands will be aligning themselves accordingly. So we have here H2O I am placing here, H2O here, and then one H2O here in this cone. So these 2 ligands came nearby, identical ligands came nearby, and then the rest of the ligands of amine I am placing in each corners of the octahedral geometry. NH3, NH3, NH3. Okay. So the cis form of the given compound is ready. This is the cis form. Very simple. And another thing we have to remember is, here we have in this compound we have a counter ion. The counter ion is Cl, Cl3. Each Cl will be carrying 1 minus charge. How many Cl we have here? 3 Cl we have here. That means here we have 3 minus charge. That is, what is the use of a counter ion in the given compound? Counter ion is used to neutralize the charge on the coordination entity. When a counter ion is used, it means the coordination entity is carrying a charge. That means it will have a 3 plus charge in it. Because how to find it out, you know it. NH3 is a neutral ligand, 0 charge. Aqua is also a neutral ligand, so the charge on aqua is also 0. And so the cobalt is having 3 plus charge. That 3 plus charge is whole for the whole coordination entity. So we have to neutralize that charge. So we place a negative ligand here, which is having a 3 minus charge. So both the charges will be getting neutralized. So we have to write it. We have to show it here in this cis and transform also. So here we have 3 plus charge and we have 3 Cl minus ions here. Okay. So this is the cis form of the given coordination compound. So we will name it as cis diaqua, cobalt, 3 chloride. This is the name of the given coordination compound in its cis form. Now let's see what is the trans form. It's clear, I think. Cis form is clear. In the same way, we will do the trans form of the given compound too. The trans form, here we have cis form we have already seen. So here we have two aqua ligands here that I am placing away from each other. H2 here and H2 here. So those two ligands are placed as far apart as possible, just opposite, 180 degree. So that became trans, and the rest of the ligands will be placed in each corners of the given octahedral geometry. NH3 here, NH3 here. So this is the trans form, and then we have to see the charges and the counter ion. We know that we have 3 plus charge on this particular coordination entity that we have assigned here, and then 3 Cl minus ions are there, that too we had shown here. So this is the structure of the trans form of the given coordination compound. So we will write trans, same as you name the particular compound, tetramine, diaqua, cobalt, 3 chloride. So the name of we have drawn the structures of cis isomer of the given compound and trans isomer of the given compound, and we had named them. So that's enough. You will get full mark. Okay. Let's see one more very important question. Draw the structure and write the name of the given compound. COCl2En twice plus. You are familiar with these ligands. So by looking into these ligands, you should be able to identify which is a unidentate ligand, which is a didentate ligand, and so on. Okay? Only then you can find out the coordinate number correctly. Only then you can predict the geometry and you can write its cis form and transform correctly without mistake. So let's see here. We have a Cl ligand and we have En, ethane 1,2-diamine ligand. And what you have to be clear about this, ethane 1,2-diamine is a didentate ligand. It is a didentate ligand. It's a didentate ligand. What it means? That means one ethane 1,2-diamine will have 2 donor atoms. In coordination number, actually we are counting the number of number of donor atoms. How many atoms will be able to provide electrons to the central metal ion and thus forming a coordination bond. Okay, coordinate covalent bond. Let's see. This is the structure of ethane 1,2-diamine. We have already explained it. CH2, NH2. So we have 2 donor atoms in the same ligand. So that we have to consider when we find out the coordination number. So this is a didentate ligand, and so what will be its coordination number? 2 plus 4. 2 into 2, it is 4. In one En there are 2 donor atoms. So 2 into 2, 4. 4 plus 2 will have the Cn, coordination number 6. Okay. Here we have the coordination number 6. So if coordination number is 6, it's an Ml6 type ligand. Ml6. That means its geometry should be octahedral. Okay. Without mistake, you have to find out the coordination number first. And if it is Ml6 type, one metal with 6 ligands, 6 donor atoms, in that case it will be octahedral. So this particular coordination compound, in this particular coordination compound, cobalt is having coordination number 6. So it should have the predicted geometry octahedral. You know which is the octahedral geometry, we have already said. So we have drawn the central metal atom here, and we had drawn a square planar structure first. And each of this corners we can align ligands, and then we have one facing above and one facing below. And then we have Cl2 here, which we can easily manage. So we are adjusting it with to find out the cis form. Okay. Cl I have kept here and Cl I have kept here. They are near. So it can be a cis form. And what about En? One En is making two coordinate covalent bond with the central metal ion. So I will write En will have one En is making two coordinate bond. One N is having a coordinate covalent bond. The other end at the end will have another coordinate covalent bond. So En will be like this. And here also then another En will form a coordinate covalent compound like this. So we have got a cis form. This is the cis form of the given structure. Cis form. Cis CO Cl2 En twice. And then we have a charge on the coordination compound. That also we have to show here. How come the charge you know? Okay. Cl2 is only 2 minus and this is 0. Ethylene diamine is a neutral ligand. Okay. And so 1 plus charge is extra here on this coordination compound. It is 2 plus. So 1 plus charge is remaining. That plus charge is shown. So it is a cationic entity that we have to show in the cis and trans form. In the particular geometry also, in the given structure also we have to show that it is positively charged. So we have shown. So we had written the cis form. Now let's see the trans form. Cl we have placed Cl2 ligand we have placed in the opposite. So it became the trans form, and then we have En here, ethane 1,2 diamine. So each one ethane is forming two coordinate covalent bond with the central metal ion, and so we have drawn it like this. One En is forming two coordinate covalent bond. So this is the structure of the trans form, and we have the charge here. Charge on the coordination entity that we have shown here. So this is trans CO Cl2 En twice plus. This is a trans form. I hope you have got we have done 3 important question answers, and you have to practice it today itself. And this is the end of our session today. Thank you. We'll see you again.